think I made a mistake. I added 2 scales. Right, well, back to 1 scale, and I'm going to delete this. I just have to rethink that anyway. Let's just commit what I just added. And then throw away this. How do we do that? Is that restore? I think so. This way or not? Okay. Yeah, that worked. Don't forget to write a description below the video. I try to make a clear one. Clear description. Well, clear. Detailed anyway. Yeah, let me think. Okay, I want to answer the following question. Which is initialized first, H direction or I think it's called extreme type of algorithm? Next extreme type. So which of these is set first? And where, I guess. It is initialized in the constructor. That's a good thing, of course. We can read it. And the test suite can set it. Let's ignore that. So it's also H direction. Well, in that case, they are both set at the same time. But H direction is also initialized in the constructor. Can also read it. Well, reading is just a debug function, also for the test suite. Can also ignore that. And it doesn't set those variables anyway. Here, H direction is set. Seems very likely that it is only set by assigning to it. There's another one. But and another one. Yep, so basically that is the way to find them all. This case it's set to left or right. If there's more than 1 0, okay, that's after we found an extreme, maybe even a minimum. No, I think it's an extreme. Then we fit. Hello, empty code. Then we fit a fourth degree polynomial, and I'm trying to find the extremes of that. And if those exist, or at least one of them, and they're legal because of this block here, then I set H direction. Yep, okay, makes sense. So H direction is the direction in which we are going to look for the next extreme. Handle local extreme. I would say that is what we just saw as well, because that also happened. I think this is the same function, no? Call an extreme. And then make a fourth degree polynomial fit here. Strange. So it's set here and then overridden down. Let's see what happens after this point. Then we jump to here. Okay, then its direction is no longer undecided. So if it is well set, then it's not set again. Otherwise, the direction is based on what the where W was changed to, apparently. So if the new W is larger than the previous one, then we go to the right, and otherwise we go to the left. Well, that sounds logical. And this is also only set when horizontal direction is undecided, though. Based on W value being less than W21, which I think is exactly the same thing. So W21 is I think the W value of the current history sample. W21, let's find that. Yeah. So current history is W2, and then the W value of that is just W value of the current history. So that's not changed anymore, I think. Might as well make it const. Why is it not const? Try making this const. So that then is being used here, which makes this equivalent to where we would end up after leaving this scope, namely here, and then H direction is still undecided, so it would be that. If H is undecided, well, it is. I don't know, that's the case that we are interested in. Then if W is less than, and this was equal to this, yeah, it's the same thing, right? To subtract history from both sides. Maybe I should not do the subtraction here, just do less than as well. So then it is set here, and still also set there. And this is just printing it. But here it was already set, so this is not setting it for the first time, because it's just toggling the value. So the initial point where it is being set is here, which is at the end of handle local extreme. Now I have to remember that. And then the other one the next extreme type. When is that set? Print, compare, comment, assign. Compare, pass, compare, assign. That's two of them. Another assign, really, that's three. At the very least, all of them use again normal assignments. So it happens here. And that is a toggle again, so that's not the initial one. I can ignore this one. It's set to minimum, and here it's set to maximum. And those are all the cases. And toggle. Set to minimum happens when or where handle approximation. Yeah, this is definitely later than the other one. I think handle approximation should maybe only be called when we have two samples. I'm not really sure though. What about the other one? This is handle abort H direction. Well, that's after jumping back to an existing minimum. It's also very late. All that too. The question is when is handle approximation exactly called? That is called here. So yeah, handle single sample is called first. Definitely. So H direction is set first. And well, in handle single sample. Handle local extreme. No. Damn it. That's a totally different thing. That's set very late. And local extreme is called here. That is after handle approximation. Yeah, so the first call to handle approximation, which happens before handle local extreme, this will be true, and therefore we will set, and this is still unknown, so we set next extreme type apparently to a minimum. I don't understand this comment. Oh, find extreme already sets it. That's the canonical thing to set it. This function sets next extreme type. And then here it is set if it wasn't set by this function. So, but okay, then it's still being set. This one is calling it extreme type instead of next extreme type. It's just set here. That's an unknown, but here it is set, also set to unknown. Well, whatever. This is the function that should set it clearly. Right, so I'm gonna assume that next extreme is next extreme type is known after the call to handle approximation, which handles here, is called here, I mean. But that happens after update approximation. Which is annoying. Update approximation. Yeah, update approximation should update the scale. I mean, the scale is a member of approximation. Just, you know, if you update approximation, then the scale should be initialized or updated. And I'm not even sure if it is possible to then, during this call, figure out if we are zeroing in on a minimum or a maximum. But assuming I can do that for now, then that minimum or maximum or critical point type should be the same as the next extreme type that is being set inside handle approximation. Right. So I'm assuming that handle approximation also gets yeah, of course it will access the approximation. All this. And then at the moment I set the next extreme type, I should verify that that corresponds with whatever I did set as type on the scale of the approximation. And then if that doesn't work, then I hope to run into that assert and then understand what is going on. Because right now I have no idea why that would go wrong. Or for that matter, if I can even initialize it inside this function. We'll have to see that, but okay, I'm going to try that, and then if that succeeds or I write some code, then at least it should be the same as what we figure out here. And yeah, it's all based on the approximation itself, so it should work, I guess. Theoretically, I should just remove the code from here and then put it inside the update approximation. So this function, yep, there's the approximation again. This function sets a next extreme type, and that must correspond with the extreme type stored in the scale. Let me see if I understand this. Next extreme type, it has an extreme type minimum unknown maximum, right? Yep. Okay, so yeah, this is also it's all very I don't know the word, hand wavy, say. Anyway, it might be set here, so I could do my test down here with as comment the extreme type set by find extreme for the minimum, because we are going downhill. Must correspond with the scale type. My display contrast. Where do I find that empty code? Maybe you can look it up. I think it's. I don't see the type. It's a BenQ. Type must be on it, right? Yeah, BL2411. That's my monitor type. And now you want to know my CPU. No, I don't have an Intel on my CPU. I haven't had one for a long time. I haven't changed it. Who do you think I am? Well, I don't really understand your question, because you can't see what I see. It's a screen capture, but whatever I set my monitor to, it's just for me. I'm the only one who sees that. I have my brightness extremely low. I don't know what I did, but I haven't changed it in years. And since you can't see it, I don't see the point of asking the question. Hello, Nick Vorso. So next extreme type is not unknown. So it's either minimum or maximum. If it is minimum, then I pressed the wrong button. If it is a minimum, then the other one must be at minimum as well. The other one being, in algorithm, I need to get to scale. And then from the scale, we can get the critical point type. This is just type. And that must be then also minimum, right? But it would be okay if it is inflection point, I think. I mean, it just means that the scale didn't see a minimum yet. Or no, I don't know. Let's assert if it is not minimum. I mean, let's make sure that it is just minimum in that case. So critical point type minimum. And the same for maximum, of course. Watchy. Is this correct? If this is false, then that must be false. If this is true, then that must be true. Yeah. I think this is correct. One of these is true, and then the other, this also must toggle. Can't make anything else of it. Well, I can actually, but so if this one is inflection point type, then or inflection point, then I just assert. I mean, one of them has to be true. One of these is true, therefore one of these must be true, therefore I force type to be either minimum or maximum, and well corresponding with that one. Okay. Now I'm not setting it at all, so we should definitely assert here now. Let's see if it compiles at all. There is no scale. Oh, this is algorithm. I need a scale of the approximation. This is algorithm. Okay, where's my? I have an approximation here. Right. So we need a approximation dot something. Now I guess I called that scale. What else would I have done? And it compiles, and it really compiles. And we do gradient descent test suit, and we crash. False. An extremely early failure, I must say. That's test suit printed the whole 3 lines. Oh, interesting. Okay, never mind. Just an in-between error. apparently critical point type is no, it's impossible. Non-minimum maximum inflection point. That's all. How can we ever not reach this? I guess I'm passing something that is on not initialized. So let's do that in the debugger. Yeah, and now it prints a lot. Still never reached. Critical point is totally not defined. Sorry, that's not what I wanted. We need type. Yep, so type is not defined. Yeah, I mean, okay. It is not defined. And since I'm printing it in, I probably should define it, right? It's just in the constructor. There's nonsense as well, clearly, so it's all zeros. So a way I can see that it is nonsense. I guess that this is not, this must be false. Yeah, if this is false, and maybe I don't even want to print this stuff. Well, that seems to be initialized at 0, that's good. I could print those. It doesn't make much sense to print these. I don't think these are initialized if it's invalid. Although it's set to 0. Maybe, yeah, I think I fill members with 0, so this is all 0. Cubic is then not initialized, or, well, also filled to zeros, yeah, okay. Now these two are uninitialized, so I should initialize this one as well, and then maybe not print that one. This one is initialized to none. That definitely makes sense, right? So that file. The type of scale that is here, and scale does not, oh, it has a default. Well, I can initialize it here then. Yeah. None. Point type none. And then when printing this stuff, yeah, let's just stop here. Print that. Type is unequal. Critical point type none. Print a critical point. Make. Run. Core dumped in false. That's just a missing implementation of update. Okay, but I thought we would assert in my new assert. Where's my new assert? Here. In handle approximation. Yeah, it's never called. Why is that never called? Skill update called directly. No, skill update is called from. Oh, what it is it? And approximation. Okay, we have update approximation. It's probably called directly from the. No, it's not. Okay, so apparently update approximation called before handle approximation. Yeah, it is. I remember that even now. Just looked at that. So first update is called and then handle. And this contains my new assert. Which then compares those values, assuming that it got set here. Yeah, okay. So now I have to implement this function now. No, I don't. No, update skill must be implemented. So either that is called directly. So not true. This calls skill update. Is that it? Is that the one, man? Yeah, that's the one. Yep. Okay. So rather we going to add, I think, approximation add. And then here the skill update is called. On this, initialize the cubic. So what I do if this is true, if we have only one sample, then I'm not creating a cubic, not initializing it rather. And I'm initializing the parabola to a straight line. I think I should get rid of the parabola completely, simply initialize the cubic to a straight line. Which then also, well, which then clearly does not have a minimum or a maximum, nor an inflection point. It doesn't have anything. And then what should we do? Oh, scale update is only called when the number of relevant samples equals 2. Didn't see that one, so definitely, yep, we got here, and we did initialize the cubic. At the moment this is called. Good, 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 good. So then the relevant samples itself must be at least 2. No, shouldn't it? What the hell is the difference between number of relevant samples and relevant samples? Oh, relevant samples are the samples themselves. Yeah, so I just passed 2 samples here, period. Right, then in order to know if this is a minimum or a maximum, well, if you want to correlate, or what is it? Yeah, if we're going to use this approximation for finding a minimum or for finding a maximum, we need to know, I think, at the very least, where the last sample is. I'm not convinced though, you know, not convinced. No, I'm not convinced at all. You cannot really know this. Why? Or maybe, no, also not. Maybe I should pass H direction. If H direction is set, it's easy, right? But that got set really late. No, extreme type is better. If next extreme type is set, then you can use that. And then if it is not set, that only happens, I think, after, well, like the very first call. And in that case, we probably go to the nearest extreme. Then that code already exists, I think, yes. And that's it. Then that same code I should use here, but only if that other code is going to be used. Yeah, so that has to do with next extreme type still being unknown, I think. Is it just next extreme type? Yeah. Let's get that. I'm going to pass next extreme type. Well, not really, but now I know what it is. So the extreme type. Defined in a header. I want to pause that. I want to pause it just in case we can use it. Current is replacement, comma, next extreme type. Can we print the thing? No, we cannot print it. Oh, actually, we can print it. Yeah. Still called the V direction here. The ancient name. Probably should rename that to extreme type. This is set to unknown upon reset, right? Where's my reset? Or not. Reset. It's not doing that. This is approximation. Wait a minute. Scale. No, I got lost. Not enough, blah blah blah, expected 3. guess I can just pause this extreme type. Looks like it is known, so and if you have to pause something, then let's pause that. We have another add here, add on approximation. Another one. I'm not convinced, I must say. Now I have to understand this again. Horrible. This adds SL and R. That is left and right. Two samples. Why is the extreme type known? Absolutely nobody gets this. Yeah. Okay, so this function does not have my new extreme. Which function did? It's being passed to add. Printing, initialization, add gets it, doesn't do anything with it probably. Okay, so I have to edit that function and pass it along to where I want to have it, which is this update, right? Which update? Well, I don't know. Scale updates. Pass it on. It's not an afterthought, it's pretty important. Maybe I should put it at the first place. Okay, scale update. Gets it here. Yep, and now we have it here. Unbelievable that I just want to write this function. For some reason I'm only changing other code. Yeah. I guess now I cannot think of anything else. then actually start to write that function. This extreme type is unknown. That is defined in the header. Extreme type .h. Isn't that convenient? Stupid keyboard. Make it, make, and still it doesn't work. Too few arguments. Oh, there's another update called here. Ah, right. Approximation. That's the same bloody problem, doesn't it? Yeah, it's kind of nonsense. Don't need to pass that. That is, we can extract it from the scale already. It should have been set. Just set it to. I just set it to whatever the scale says that it should be. So extreme type is, and then we just get it from the scale. The extreme type, well, I don't have an extreme type, but we have the critical point type. So that is just type, I think. Again, type. Critical point. So it must be a minimum or a maximum at that point. It cannot be something else. Okay, let's just do it like this then. Critical point type is scale dot type assert critical point type equals critical point type minimum or maximum. And every assert must have a comment. It's like I really don't want to type it at this point. I just want to continue, but I force myself to do this. And you should too. Every assert must have a comment. Really. Trust me. Might as well not add the assert if you don't do that. As per this. So that's my thought for adding the assert. But it's not enforced in this function. It's something that is completely outside this function. So it's logic that is engraved in the code, but not locally, not even in this object. And then I add an assert. If it was enforced inside the object itself, then I might not have added the assert, because then it's just a given of the object, and probably then that is described in a comment somewhere of the object code. But this is enforced, more on a more broader scale. So I really want to make sure that it is correct. Especially because I'm relying on it, of course. It's not like that I think I think it must be this or that. I mean, I couldn't care less. No. The only reason I care is because the line below that, I'm using this fact. Otherwise, I wouldn't even, if you don't use it, then yeah, who cares if it is true or not, right? So if it is a minimum, then okay, it's minimum, and if it's not a minimum, then apparently it's a maximum. So it's one of them. Yeah, so it's a fact that if this is not true, then I set this to maximum, but then better that one is maximum, of course. Otherwise, you could do something like, if it is minimum, set it to minimum, else, if it is maximum, set it to maximum, else, I don't know what to do, assert. Scale update results. So now I'm passing this. And I don't have to pass it here. Could still pass it to this function and then add another assert that makes sure that what I figured out here equals to what it should be. But I think that it's almost trivial the case, so don't need to test that. Right, now what was the thing that last crashed? I have no idea what change I made. Still the same thing. Yep. Still didn't write this function. Unbelievable. Implemented, finally. Well, hey, now we have the next extreme type here. Okay, let's have a look. This is the old code that worked for a parabola. So what we do here is you get the W value of the vertex of the parabola, and the only way I can do that for the cubic is if I know what the critical point type is. So we have to really figure that out first. So my scale has this variable here, type, and I want it to be defined correctly even, but at the very least it must be defined. The shitty thing is that it could even change if it's already defined. I think it can change from inflection point to minimum or to maximum. Man, I really see. I really need an example where shit like that happens before I understand why that would happen, and then how to solve it. So we have to research. What is the word? Research to a lot of research. So if the type is still, and now suddenly it's not called type. I did have a color, so it should have be able to find something. No, that's it. Okay, I just had to run a CMake, make CMake. Right. So if this is still none, then I want to set it because I just need it here. If it is not equal to none, then it better corresponds to whatever is being passed here. But if that is unknown still, then there's nothing to test. And then I just have to set it. No, wait a minute. Is that even possible? Is it possible that this one is set and that one isn't? Yeah, that's probably possible. I'll think about that in a minute. Let's do my assert first. So I want again that they correspond in the same way as before. So that is again, I guess, next extreme type equals extreme type minimum equals type equals critical point minimum. And then again the same thing for maximum. This is really, really bad comment, by the way, in case you're looking at it. I would interpret it as thinking that this will never fail, but I'm not 100% sure. But just a second ago I said, and why would you even add it? So it's not clear why I need this to be true at this point here. So I think the comment is just wrong. It should have given an argumentation of why I think it is true. So more than 2 relevant samples, or both are invalid. useless. Yeah, I'm not having very good argumentation here. I just want to see why this fails. Okay, so we can wait until this asserts, and otherwise they correspond, which is nice. And if the type is currently not set, then obviously if this one is set, I just copy it. That's easy. So if next extreme type is unequal unknown, I guess. Then I just set the type to one of these, depending on if it is a minimum or a maximum. So if next extreme is a minimum, then I set it to a minimum, and since it is not unknown, it must be a maximum if it is not minimum. Else, we don't have a hint, I'll call it. So now we have the problem that apparently we don't know yet if we're looking for a minimum or a maximum. And we didn't take the decision about whatever this skill refers to either. We don't know anything. The only thing we have is the new approximation. And of course the samples that were being used for that. But I really have to set type to something. Yeah. Now I guess, suppose I set it to the wrong value. And the next call, this value has probably been initialized. And this is false because I set it here. And then we do this check. So in the later call, I'll get the actual value that I should have figured out here. So then it will assert, and then we can figure out under what circumstances this code that I'm going to write now did not work, and then maybe I can fix it. So it's not super important to get it right. I think that a pretty good guess is to set it to the best, no, to the closest one, I think. Like I said, there's already code that exists. I think that does this. I should find it first. Now I need to remember something that I can grab for. What is that code doing? I think that is the code that is super early. Also in the case of an unknown next extreme type. That is just the code that sets the next extreme type, obviously. Yep. So if I search for next extreme type equals or becomes, then shouldn't we find it? What is this? Oh, there's a debugging, yeah. This is one of these two, or well, both, I guess. Super confusing. Apparently I was wrong. Nope. It's just printing. No. What the fuck, man? I mean, if we have a function with a maximum and we drop in on the side of that maximum, then we do a local polynomial fit of the third degree. So we find a cubic, and then we have to decide if we go to the maximum or to the minimum. I'm pretty sure I have that code somewhere which then decides to go to the maximum because that is closer. And I have no idea why I couldn't find it by looking for these patterns. Let me just look at the entry code then. So, oh, that's definitely not what I meant. Algorithm event, no, man, what you're doing. I meant algorithm itself. This is the entry point. So we come in here with some new sample, the very, very first sample. Okay. Add it to the history. Draw it. Do stuff with the energy. That is not the case. Update approximation. Okay, that's just a linear thing then. And then we do, that's a 1, then we do a handle single example. I believe that this one actually is already deciding which way to go though. So maybe I was wrong and I just changed it. Not defined yet. Set it to something. If H direction is undecided, yeah, it's not being set. At least not yet. Just step in some random direction. Here too. Okay, what's wrong? So H direction is not set. It didn't handle single sample. Return. Then we get called again. We do the same thing. Now we have 2 samples, so we skip over this. We call handle approximation. I'm pretty sure that that should do what I just said. So we have our approximation. This is the first call. Use the what you're talking about. Extreme type is unknown at this point. That's what we're going to decide. Yes. New W. Find extreme. That function should do it, right? Yep. That this is what it should do. And then if it is still unknown, then that's because there were no minimum or maximum. And I just go downhill and set it to a minimum. So this is the code where I can find what I'm looking for, I think. Find extreme. We read the cubic. Yeah, here we don't have an extreme, so that's not interesting. Here we do have extremes. So this is the minimum, this is the maximum. I assume we could calculate that. Otherwise, I'm still using the purple here. No, I can skip that. If it is still unknown, this is the algorithm. So it depends on the restriction as well. Yep. See, here it is set, and I missed that because I was looking for where extreme type was set, but was assigned, but it is actually being passed as a non-const reference to this function, which then sets it by assigning to that thing. Boy oh boy, that's why I couldn't find it. So now if this way we do find it, these are all the places where this thing is assigned. Loads and loads. Yep. Can I somehow use this code? So I definitely don't want to duplicate it. So what it is using is, this is output. Extreme type is, I think, also an input and output. But I'm only interested in where it is still unknown, so we can assume that it is unknown, and then I want to know where it is being set to. But that means that I also need to know the restriction. Probably, because I think we're dealing with the initial boot up here. The restriction is also none, so no restriction. But I'm not sure. Okay, so we might need the restriction value, and then it just has the cubic, and then in this case I should set the other thing to the inflection point. The restriction is only used to decide on the region output, which I don't care about here. Well, I don't care about where I have to write that other code. No, I think I should just call this function. So that's called on approximation, and I can call it as soon as I have the cubic. I think, yeah, if I set this to unknown and this to none, then it seems very unlikely that it returns unknown, except when there is no minimum or maximum. In which case we can use that as well. Then that just means use inflection point. So maybe I should make sure that find extreme is being called before I call the update on the scale. I think that this little block should be done before this function is called. But then I need something else to know that we have to enter here to continue with this. This gets a new W. I could pass that as well. I guess I can make this a boolean which I pass, and the new W we can pass as well, which is then only valid if the boolean is set. And then I can move this this call to before this is being called. It is also calling find extreme. Maybe it is necessary anyway. It's just talking about the region, yeah. So yeah, next extreme must equal to unknown, or can it still be unknown if we get here? Probably. Okay, before I make this change, let me have a look again where this was called. See, if I take that first piece of code out of this function, then I can call that before calling this, I think. Because yeah, or not. Wait a minute. Update approximation. No, I cannot. I can call it from inside update approximation. So if we go inside update approximation, then we can, I think, man, I had expected a different function. Guess it would be inside this add then. I want to call this code after that the cubic is initialized, but before we call scale update. So it must be done in between here. It can be done in between here. Or rather here. It can be done here, I think. Meaning no here. So I know that it is always done, even if we skip this. My God. This is annoying, difficult, right? Yeah, I think I'll think about this tomorrow. So time to go to stop, right? A bit. Yep. Play some chess. No. Cannot do that. Man, difficult. Should have gone there. I should have gone here. Yeah. It was already completely lost. He gave it away with this move. Well, I had a check here myself. Will I do nothing? Oh, it's bad. Everything is bad. A drool. Nobody knows why that is a drool. This is so bad. I mean, what is the threat? So I do this. So bad. He wants to stop my pawn first. And then I have extra defense. Okay, still this attack. Now my bishop is good. Gotta be kidding me, dude. That was the reason why I put my bishop there. Do my own attack. That this is -4 for black. It's completely amazing, isn't it? I just got 1 pawn more. Well, 2 if you count this one. You can just take here, but it is not doing it. It just goes here. Okay, can't allow this pin apparently. Okay, that's then very annoying, yes, because now this one is attacked as well. And then my rook has to give up the pawn. So tactical. Why would I attack the bishop? It just takes my pawn. Why not this? Get the pawn back. Oh, now mate in 8. Yeah, I did 2 moves myself. I want to give away pieces. The bishop or the rook or anything, but not giving away a piece. Why? I like this move best. So all the arrows that I see. Check. Take it. Mate. Well, okay. So I did that one, that was bad because he did that. Now what I just go back? What's the difference? That rook, alright. Now we do some attack of ourselves. Check a check. Interesting move. No, black has a horrible attack. Apparently, I don't see it, but so many tiny moves. Oh, that's a weird move. I mean, can you not defend this somehow, maybe? Yeah, I guess not. I guess you cannot do that, right? Or we do something stupid like this. Oops. Long distance check. Why is white completely lost? Okay, we go away. Okay, wins a pawn. I'm not even taking it back, apparently. Why? It's a piece then. So I'm just taking it back. And then my king is completely open. That is the problem, I guess. I have to run away. Just going to develop, see what happens. Made in tin. Check. Check. Interesting check. 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 Mate. Okay, I sold that one. I don't understand this move. Well, how can this be wrong? It's made in 10 then instead. Okay. Never mind. This, however, made in 15. Oh, no, okay. This is faster because you just remove this pawn. Oh, because this pawn is now no longer defended. Looking so far ahead. So we still try to defend like that. Just takes it, and then we go here, and he takes here. This is also not defended. Yeah. So it's kind of that check against is the knight sacrifice here. So he sacrifices the knight here, so that I can't. So that I can't sacrifice my knight here. Apparently. So, but if you do this, yeah, even still, you know, this pawn is still protected. But okay, you can give check and go here, and then why not? Oh no, sacrifice a rook, yeah, why not? It's with check. Of course you take it, and then you get almost the same thing, I guess. You're not gonna give away my bishop, no. No, I don't do that. I go here. The mate in 3. Yeah, what? No, this is better mate. Yeah, much better. Why am I not in bed already half an hour? Yep. Good night.